Factoring quadratic expressions when a is greater than 1. When we're factoring trinomials in the form ax squared plus bx plus c, remember that your x squared term should be first, x should be second, and your constant should be last. In this lesson, we're going to focus on how to factor these quadratics when a, the coefficient of x squared, is bigger than 1. The method we're going to use is grouping. So our very first step is to multiply a and c together. So we're going to take a, the coefficient of x squared, and c, our constant, and multiply them together. In this problem, that gives us negative 30. Then in step 2, it asks us to find the factors that add or subtract to make b. So this is a lot like when we were factoring quadratics when a equals 1. We're going to find the factors of 30 first, 30 and 1, 2 and 15, 3 and 10, 5 and 6. Then we have to find the pair of factors that subtracts to make negative 7. So 3 minus 10 will give us a negative 7. So we want these factors. Now this is where our process is going to be a little different from factoring trinomials when a equals 1. Positive 3 and negative 10 do not take us straight to our final answer. Instead, we have a few more steps. So step 3 tells us we need to replace bx with the two terms using the factors from part 2. So positive 3 and negative 10, we're going to use those factors to replace this middle term, the negative 7x. So instead of negative 7x, we're going to rewrite that as positive 3x minus 10x. Then, this is really, really important, okay? Don't forget to bring down your first and last terms. You need to make sure that your first term, that 6x squared, comes straight down. And that last term, the negative 5, comes straight down. Okay? We only use those numbers to multiply and find the factors of negative 7, but they need to come straight down for the next part as we move forward. Now let's look at step 4. It says group the first two terms and the last two terms. So let's do that first. I'm going to draw my line to group the first two and the last two. And we need to factor out the GCF from each one. Okay, so this follows our steps from the video where we practice factoring by grouping. So let's go ahead and find the GCF from the first two terms. Here we have 6 and 3 as numbers. So the biggest number we can take out is going to be 3. We have x squared and x, so we can take an x from each one. So when we take out that GCF, what we're left with here, 6x squared divided by 3x leaves us with 2x. Positive 3x divided by positive 3x leaves us with a positive 1. Remember, they do cancel out, but you still have a positive 1. It doesn't just disappear. Now on the right side, after the split, remember, if that first term is negative, that means your GCF needs to be negative. And then we have 10 and 5, so the biggest number we can factor out is 5. This one has an x, this one doesn't, so it's just going to be a negative 5. So now let's divide it out. Negative 10x divided by negative 5 leaves us with positive 2x. And a negative 5 divided by negative 5, again, that cancels out and we have a positive 1. So just like when we were practicing factoring with grouping before, after you've divided the GCF out on each side, those two are equal to each other, which is what you want. So to write our final answer, we're going to take the two GCFs in the first set of parentheses. So take 1 here and 1 here, 1 from each side, the 3x minus 5, and then your divided terms, the 2x plus 1, the thing that's equal on both sides, that's going to go into the other set of parentheses, and this is your final answer. Now again, if you wanted to double check to make sure you did this correctly, you would just multiply these polynomials and see if you get the original problem as your final answer. So I'll walk through that with you one time to show you how to check your answers. So multiply the first ones. That's going to give us a 6x squared. Multiply the outsides, 3x, the insides, negative 10x, and the last one's negative 5. You'll combine your like terms. So we have 6x squared minus 7x minus 5, and that is the exact problem that we started with, which tells us that our final factored answer is correct. Now let's go ahead and do some more practice. So let me walk through the first one with you just to walk through those steps again. So our first step is going to be to take A and C and multiply them together. So we get positive 12. Then we want to find the factors of 12. 12 and 1, 6 and 2, 3 and 4. Our next step is to find the factors that add to make negative 13. So again, if you're adding to make a negative number, we need both our numbers to be negative. So that's going to be negative 12 and negative 1 add up to make negative 13. So we're going to split that middle term with a negative 12x and a minus 1x. Before moving on, don't forget to bring your first term and your last term straight down. Now we're going to go ahead and split our terms and find the GCF from each side and divide. So on our left side, we have a 3x as our GCF. So 3x squared divided by 3x leaves us with just x. And then negative 12x divided by 3x. Sorry, that's actually going to be x minus 4. And then on the right side, after the split, our first term is negative. So again, our GCF has to be negative. 1 and 4 don't have anything in common, and this one has an x and this one doesn't. When that happens, you still have to take out a GCF, so it's just going to be negative 1. So negative 1x divided by negative 1 is a positive x. Positive 4 divided by negative 1 gives us a negative 4. And again, after you divide the GCF from both sides, what you have left over should be equal. So for your final answer, you're going to take one GCF from each side, and then you're going to take what you had left over that's equal on both sides. And there is your final factored answer. Go ahead and pause, try example 2, and check back with me when you're finished. Okay, let's go ahead and walk through example 2. So we're going to take 2, multiply it by negative 15 to give us a negative 30. Then let's go ahead and find the factors, 30 and 1, 2 and 15, 5 and 6. And then we need to find the pair of factors that subtracts to make a positive 1. Remember, that's an invisible 1 right there. So to subtract to get positive 1, it's going to be 6 minus 5. So we're going to take those factors and split our middle, negative 5x plus 6x. And then we're going to go ahead and bring down our first term and our last term. Then we can split the middle and find the GCF of each side. So on the left side, 2 and negative 5 don't have anything in common, so it's really just an x on the left for our GCF. And on the right side, it's a positive, so our GCF will be positive. So 6 and negative 15 have a 3 in common, and that's it. So when we divide out the GCF on each side, 2x squared divided by x is 2x. Negative 5x divided by x is negative 5. And on the right side, positive 6x divided by positive 3 is 2x. And negative 15 divided by 3 is negative 5. So again, as we're getting ready to write our final answer, make sure that after you've divided the GCFs, those are equal. So in one set of parentheses goes one GCF from each side. And in the other one goes one of what is left over that is equal on both sides. And there's your answer. Go ahead and pause, try example 3, and check back with me when you're finished. So let's walk through example 3. We're going to take A and C and multiply those together. Gives us positive 16. Let's find our factors. 16 and 1, 4 and 4, 2 and 8. Now we need to find the pair of factors that adds to make positive 17. So that's going to be positive 16 and positive 1. So let's go ahead and split that middle term, 16x and a positive 1x. And again, don't forget to bring down your first and last term. Now we can go ahead and split our sides and find our GCF. On the left side, your GCF should be 4x. And on the right side, you don't have anything in common. We are positive first, so your GCF is just a positive 1. So when we divide those out, over here, you're going to be left with an x plus 4, and on the right side, you have an x plus 4. So again, that means you did it correctly, that these are equal to each other. So when we write our final answer, you take one GCF from each side, and then you take what was left over that is equal on both sides, and that is your factored answer. One last example. Go ahead and pause, try it on your own, and check back with me when you're finished. So let's take A and C, multiply them together. We get a negative 48. Let's find the factors. 48 and 1, 2 and 24, 4 and 12. We have 8 and 6. We have 3 and 16. That's a lot. Let's just stop there and see if we can find the one that we need first. So we need the pair of factors that subtracts to make positive 13. Okay, so that's going to be 16 minus 3 gives us positive 13. So let's go ahead and split the middle. Negative 3x plus 16x. And then don't forget, we need to bring down the first term. And the last term. And then let's go ahead and split our factors. Split our terms, and then we will find our GCF from each side. So on the left side, the GCF is just x. On the right side, we're going to have a positive GCF. From 16 and 6, we have 2. And then let's go ahead and divide them out. On the left side, we're going to be left with 8x minus 3. And on the right side, an 8x minus 3. So it's a good thing that these are equal to each other. So then we can go ahead and write our final answer, which is 1 GCF from each side. And then what we have left over after dividing them out, what's equal on both sides. And that is how we factor trinomials where a is greater than 1. That's it for this lesson. I'll see you in class for more practice.